Alright, before we get started here, I wanted to show you, this is one of my most prized possessions right here. Oh, this is my severed head. Check this out with this eyeball here. That's so gross. But anyways, what's actually cooler isn't the head so much as it's the stand that it's sitting on. I always was fascinated by this if you look carefully. It's got 3 pieces to it, right here, 3 pieces. And you'll notice, I'm holding this piece here, I want to make it vertical. And this piece right here, now if you look, you'll see that those 2 pieces, the one that I'm holding down here, right, the one I'm wiggling, and the one I'm holding over here, they're not actually attached to each other. And if it weren't for this 3rd piece right here in the middle, if it weren't for that 3rd piece, I could slide this right off, but it gets stuck because of the 3rd piece. In fact, no matter which 2 I pick, it's the same story. I pick these 2 here, right? The vertical one, see, it's not actually attached to the one that I'm sliding up and down here. If it weren't for the 3rd piece, it would come right off. So all these 3 together, no 2 of them are actually attached to each other, but they can't come apart. And this has to be carved out of like a single piece of wood, which I think is also kind of fascinating. I can't imagine, like, I'm not, much of a woodworker, so I'm not sure what that would take to carve that out. But these are called, by the way, there's a name for it. They're called Borromean or Borromean. I think it's Borromean rings. That's pretty cool. If we had compass and straight edge in school, we could draw pictures of these. Kind of neat looking. Anyways, let's do some Khan Academy while we're at it. So we already looked at these. So let's take a look here. So Pythagorean Theorem challenge. Let's skip that one for now. And let's go... Oh, what the heck. Let's do it. Pythagorean Theorem challenge. So let's see, let me get this paper here. Now, I think these problems are probably going to be challenging since it's called a challenge. Let's take a look. Let's see. A flagpole broke in a storm. It was originally 81 feet tall. 28 feet are still sticking straight out of the ground where it snapped, but the remaining piece has hinged over and touches the ground some distance away. How far away is the end of the pole from the base of the pole along the arc? So first of all, we'll draw a picture of this. I'm gonna sketch. Here's our pole, right? And then it's this is before. Yeah, you can't see this, but you'll see it in a second here. Okay, 81 feet, and this is 28 feet. Okay. So the trick with some of these is you have to remember there's always going to be a right triangle in here somewhere. So there's our original pole, 81 feet, and it's been broken right there. And hey boys, hey, I need you to quiet down a little bit, all right? Thank you. Yep, just for a little bit. Okay. So 28 feet sticking out. And we're trying to figure out what this distance is. Where did the end of the flagpole fall over? So there's my right triangle. But I only have one side, right? The 28 feet. But, well, we can figure out the other one because originally it was 81. So this is going to be 81. Take away the 28 feet that's still stuck in the ground. See, if it were 81 minus 30, that'd be 51, 53. 53 feet. So we've got A. And that'll be C, and we're trying to find B. So I've got, let's see, A squared plus B squared equals C squared. So I've got 28 squared plus B squared, I don't know that. And C is going to be 53 squared. I'm going to use calculator power here. I don't know what 28 squared is off the top of my head. Let's see here. So let's see. 28 squared. Boy. Is 784 plus b squared, and then I've got 53 squared. That's 2,809. So let's see, we're going to subtract 784 from both sides, and that's going to give us b squared equals 2025. So we'll take the square root of each side. I'll have to turn my calculator sideways. That was 2025. So clear. I'll do square root of 2025. Oh, 45 exactly. No doubt. So 45, which means that the side B is 45, and that appears to be what we were after, right? Because I think it was we were supposed to find how much of the flagpole is still. Let's take a look here. How far away is the end of the pole from the base of the pole along the ground? So that sounds about right. 45 feet. Let's see. Good deal. Hey, all right. Let's take a look here. Julian jogs 2 kilometers to the east, and then 4 kilometers north, and 7 kilometers west. How far is Julian from his starting position to the nearest tenth of a kilometer? So when it says to the nearest tenth of a kilometer, that suggests to me that our answer will not be a whole number. It's going to be rounded off somehow. So let's see. I'm just going to do a little sketch here. 2, 4, 7. So let's see. Let's see here. Down. All right, now. Well, I'm looking for a right triangle here, and what I think I'll do is I'll cut this up here, which means that if I want this part of the right triangle, the whole length here is 7, so I take away 2, so that makes this 5 and 2 over here, and this, of course, is still going to be 4. So this will be A, B, and C. A squared plus B squared equals C squared. 5 squared, 4 squared, C squared. 25, 16 equals C squared. 625, 41 equals C squared. Now I'll take the square root of 41, which, get my calculator out here. Let's see, square root of 6.403. 6.403. I want to make this a squiggly equal sign to remind myself that's approximately 6.403. I had to round that off. So let's go take a look. So it looks like this would be approximately 6.403. Makes sense. It's the longest side of the triangle. Let's go back and take a look. Now we were supposed to do some kind of rounding here. See, to the nearest tenth of a kilometer, so 6.403, well, 6.4, a tenth kilometer, that's 1 decimal place. So 6.4, next digit would be 0, so we leave the 4 alone. 6.4. All right. And let's take a look here. The tetrahedron superyacht, which they show a picture here. So a tetrahedron is it's a solid that has is made up of 4 equilateral triangles. So let's see. A regular tetrahedron with edges that are 20 meters long. The distance r from one corner to the center of the base shown. One corner. Okay, so one corner. So this r here actually seems to stretch into the center of the shape. Is 11.5. So we're told the edges, so it's this distance down here. If I can draw in here, let me. Yeah, this distance right here is 20, and r is 11.5, and we're supposed to find h. So it'll be a squared plus b squared equals c squared, where c is 20. Okay, so let's take a look here. A squared b squared c squared, 20 squared, 11.5 squared, and that b that we're solving for is the height of the tetrahedron. And I won't finish that up because you can do that on your own. But the key to all of these is you just have to take a look and find where's the right triangle, right? Because there's a right triangle in here somewhere. Right? And then just make sure that you plug your numbers into the correct spaces. Of course, if you get it wrong, just go ahead and look at how they solved it so that you can kind of get a clue for the next problem. Yeah. And good luck with these. Let's see here.